Hi everyone, we have question 9 of the exam practice questions. Question 9 is, what is the smallest number greater than 100 that is divisible by 2, divisible by 10 and divisible by 4? So we have to solve each part separately. Taking a start with divisible by 2. We had in the exercise questions practiced the rules for the division, and according to that, a number is divisible by 2 if it ends in 0, 2, 4, 6, 8, means a number that is even, that is divisible by 2. So, and in here the condition is that smallest number that is greater than 100. Since the number must be greater than 100, so we start checking with 101. 101 is odd and it is not divisible by 2, and because it doesn't ends with 0, 2, 4, 6 or 8, so therefore it is 101 is not divisible by 2. Coming to 102, it ends in 2. It's an even number and it's divisible, as we have checked in here. 2 multiplied by 51 is equal to 2 multiplied by 5 is equal to 10. Then we bring down 2. 2 multiplied by 1 is equal to 2. It completely and evenly divides the number. So therefore 102 we can say is the smallest number greater than 100 that is divisible by 2. The next number is it is asking a number greater than 100 divisible by 10. A number is divisible by 10 if it ends in 0. So the number must be, and the second condition is that the number must be greater than 100. So we start checking from 101 again. 101 again, it ends in 1. 102 ends in 2. But for the divisible by 10, it should end in 0. From 101 to 109, none of the numbers end in 0, so they are not divisible. But 110, it ends in 0, and in here, as shown in here, 10 multiplied by 11 is equal to 110. It's evenly or completely divisible, so therefore 110 is the smallest number greater than 100 that is divisible by 10. The third part of the question is divisible by 4. So as per the rules, a number is divisible by 4 if its last two digits form a number that is divisible by 4. So in here again, the two conditions are, that is, the first one for the division is that a number, it should be, the last two digits must be divisible by 4 and it has to be greater than 100. So again, if we check from 101, if we divide the last two digits, it is 0 and 1. If we divide it by 4, it gives us 0.25. If we divide it by if we divide 02 by 4, then it will give us 0.5 something. Let me write it in here to show you. So 101. So in here 0, 1, the last two digits. If it's divided by 4, it will give us 0.25. 101, this is 2. So if this is being divided, the last two digits, that is 02, if it's divided by 4, it gives us 0.5. If 103, the last two digits are 03, 3 divided by 4 gives us 0.75. 104, if we take it, the last two digits are 04. So 04 divided by 4 gives us 1, a whole number. In here, these are not whole numbers, so we say that they are not completely or evenly divisible. In here, when divided in 04 being divided by 4, it gives us even number, a whole number. So therefore we can say that 4 is divisible, completely divisible by 4. So we can say that 104 is that smallest number greater than 100 that is divisible by 4. So this way we were able to meet both the condition, a number that is greater than 100, and as per the rules, the last two digits are divisible by 4. So in here, 4 multiplied by 2 is equal to 8. 2 when we do subtraction, so from 10 when 8 is subtracted, we are left with 2.